Hi, my name is Gokul and I'm a senior solutions architect working in AWS migrations team. I'm very passionate about networking and migrations, and I'm very excited to talk about AWS networking best practices in large scale migrations. Note, this is a 400 level talk or expert level, so we are not going to spend too much time on how the service works, but rather going deeper and focus on best practices in using them. Today, I'm going to talk you through a customer journey. Example Corp has 10 data centers globally and decided to migrate their workloads to AWS. What are some of the major challenges they faced from networking perspective as they migrate first couple of data centers to AWS? And how did they address them using some of the AWS networking best practices? That's what we'll be discussing today. Before diving into the challenges, I want to talk to you about networking ownership a bit because it is slightly different in the cloud. In traditional data center world, networking team manages infrastructure and configuration on devices, but in the cloud, it's software defined networking. So you still manage the architecture, but will be managing services and its configuration in AWS. And teams who typically don't work with networking could be managing their own VPCs. So, this paradigm shift is something important to keep in mind. Now, let's talk about the challenges in large scale migrations. We are going to discuss about three, which is hybrid connectivity, centralized networking, and private DNS. First is hybrid connectivity. We should first know, why do we need hybrid connectivity? Well, it is because migrations take time. It is typically a 2 to 3 year journey as you are planning and executing your migrations. Also, there is large volume of data that needs to be moved. And you only have limited cutover window. So need to be sure you have a reliable and faster connectivity. It is also important to factor in network latency between the applications in AWS and on-premises network, as they could be having dependencies. Lastly, replication requirements between applications and associated databases need to be factored in as well. Well, what options do you have for hybrid connectivity? First, you could either use AWS site-to-site VPN. Alternatively, you also can use Direct Connect. For example Corp, due to their scale, having dedicated network connection using AWS was key. Because they were transferring a lot of data during tight cutover windows. So they choose Direct Connect. With Direct Connect, it provides you with a dedicated network connection to AWS and also provides consistent performance and reduced bandwidth costs compared to internet. Let's discuss few key direct connect considerations and best practices. After you establish the physical direct connect, you choose to create virtual interfaces depending on your needs. There are three types of virtual interfaces. The first one is public virtual interface. With virtual interface, you can connect to different public IP addresses or endpoints in AWS. This could be your S3 or application discovery service endpoints. Second one is private virtual interface, which helps you to connect to different VPCs via directly or via Direct Connect Gateway. The third kind of virtual interface is transit virtual interface, and it is used to connect transit gateways via Direct Connect Gateway. We'll discuss more about this in the later section. One thing to note is all these virtual interfaces are 8.2.1q VLAN with BGP peering. In this section, we'll specifically focus on private virtual interfaces. When we talk about best practice, first thing to consider is leveraging high availability depending on your application needs. For Direct Connect connection, as you can see on the screen, you connect your on-premise network to a co-location facility supported by AWS Direct Connect. From there, you can create multiple virtual interfaces. If you create private virtual interface, you are able to communicate to VPCs. For redundancy, you can create an additional direct connect in a different location and connect it to your on-premises and AWS region. This model provides you with location redundancy. For example.corp though, they were running critical applications, so they chose to provision direct connect from both of their direct connect locations and data centers, which provided them redundancy against both device failures and location failures. They also leveraged AWS Direct Connect failover test, which was launched this year earlier, and it helps you to test DX configuration and how it can meet your resiliency needs. You are able to shut down your BGP session for a period of time to test the resiliency for your organization. Well, this model is good, but you can connect a maximum of 50 virtual interfaces per port for a single direct connect connection. What happens if you have more than 50 VPCs and you want to leverage multiple regions and accounts like example corp? And if you want to reduce the number of BGP sessions that you want to manage? Well, all these questions are very valid for migrations. The solution is to use Direct Connect Gateway. With Direct Connect Gateway, you can connect up to 10 VPC attachments. You only need one virtual interface per Direct Connect Gateway. So you are essentially able to consolidate multiple VPCs into a single Direct Connect Gateway, up to 10 to be exact. So with this model, if you horizontally scale, you are able to reduce the number of BGP sessions you manage, which in turn reduces your operational overhead, and you are able to connect to more VPCs across different regions. To be exact, you are able to connect up to 500 VPCs across different accounts and regions. Next, one of the common questions from traffic engineering we get is, what is the best practice to control traffic out of AWS? Well, I want to be clear here. Specifically, we are talking about how to influence AWS route selection, because it's very easy to use BGP local preference to influence your decisions locally. Before we jump into the best practice, I want to provide you insight on how routing works in AWS. When leveraging VPC and Direct Connect Gateway, you have two different routing. One is on the VPC level, VPC route tables, and the other one is Direct Connect route tables. So let's jump into the route selection for VPCs. First, it checks at VPC local route, and it's even preferred even more than the specific routes. I want to call this out specifically because it's not something that traditional networking, how it works. Second thing is longest prefix match, where more specific routes are preferred. Third thing it looks at is static routes. Then comes dynamic routes propagated from VGW. And specifically in there, BGP routes over Direct Connect are preferred, then the VPN static routes, and after that, VPN dynamic routes. Moving to Direct Connect route tables, longest prefix is the first one which it checks. Next is local preference, which is very key. Third one is autonomous system number or AS path. And in that specifically, direct connect location is very important. If AWS network cost is equal, then we require AWS local preference or BGP local preference for consistency. Next, if everything is equal, then we balance per flow. Now let's look at how you can influence traffic using BGP local preference. In private WIF, we provide you with communities. There are 3 communities listed on the screen that you can use for low, medium, and high preference. Note, there is also BGP communities which are different that you can leverage for public virtual interfaces, but we aren't going to be discussing that today. To put all this in an example, we have 2 data centers, one in US East and one in West region, and they want to communicate to an AWS region in US East location. As you can see, there are 3 virtual interfaces that are being used here, 2 from East and 1 from West location, and they are sending the same routes 172.16.0.0/16. In this case, as you can see, the second route is preferred, which has the shortest AS path and is also in the local region. For example, if you want to prefer the third route, that is the traffic to go through the West data center, what you can do is use the BGP communities that we discussed. As you can see here, if you are sending high BGP preference prefix on the third route, then that is preferred compared to the first 2 routes. So the bottom line is, if you cannot control prefix length, use BGP community's local preference to influence traffic from AWS. Let's look at some Direct Connect best practices. First thing is to leverage resiliency toolkit to order Direct Connect. You can specify your application needs and it recommends you the best Direct Connect architecture. Second best practice is to leverage Direct Connect Gateway to scale and expand to different regions. Third one is to choose between dedicated or hosted connection. That is an option that is given to you. Typically, you use hosted connection if you want a partner to be involved, and that can help you speed up your Direct Connect provisioning time. Next, we recommend you to use multiple dynamically routed connections, so that way it's easier to fail over. Next best practice is to leverage VPN over Direct Connect. This is needed because Direct Connect is private but it's not encrypted. So specifically for use cases where there is a compliance requirement to encrypt the traffic, you leverage this model. The next challenge for example.com is how to centralize networking in your hybrid environment and within AWS. First, let's see within AWS. Say example Corp has moved to project phase and they built up few VPCs in their development environment. If they wanted to be able to communicate between each other, they could potentially use VPC peering. Well, VPC peering has its own pros. It's smaller at it's simple at smaller scale, and you can use referencing security groups to make it easier to manage security groups. It also supports VPCs in different regions, and you are able to have full redundancy built into it. But the cons is it doesn't support transitive routing. So you would need individual peering connections to each VPCs, and it can become a complex when we talk about it at scale. To give you a perspective, if you have 50 VPCs, you would need 1225 VPC peering connections. Also, there are some consideration on limits. From each VPC, you can establish 125 peering connections, and each route table can support a maximum of 1000 routes. What is a better solution? Well, you could leverage Transit Gateway. With Transit Gateway, you only need 4 attachments to establish full mesh connectivity. Also, it greatly simplifies networking because you could attach it to on-premises through Direct Connect Gateway or VPN connection. Remember, I said one Direct Connect Gateway can support 10 VPCs if you attach them directly. Well, this model takes you even further. The number of static routes per transit gateway is 10,000 compared to 1,000 limit on the VPC route tables. Also, the number of AWS Transit Gateway attachments that you can make is a maximum of 5,000. That gives you a lot of scalability. Diving into the Transit Gateway in a little bit more detail, it's essentially a regional service which allows you to centralize the VPN and Direct Connect. Also, it is scalable, so you can attach thousands of VPCs to it, spread across different accounts. Also, with regards to VPN connections, you can have multiple VPN connections and get aggregate throughput because it supports ECMP. With regards to routing, it's flexible because when you create a VPC, a transit gateway attachment, for example, to a VPC, it creates two ENIs depending on if you choose two subnets, and those ENIs obey the rules of that particular subnet. Also, it makes it easier to control the segmentation of your route tables. We'll talk about this in detail in the next few slides. Considerations on using transit gateway route tables. It is important to group or associate VPCs through transit gateway route tables that have the same connectivity requirements. This is because you don't have to manage separate TGW route tables individually. Also, the VPCs associated with the same TGW route tables does not enable connectivity by default. You have to configure on the VPC level to use Transit Gateway. Next, you can choose either to use VPC propagation or rely on static routes. Lastly, you need a return path if the destination VPC requires a different connectivity pattern. Customers like Example Corp can have unique access control needs. For example, if you have three VPCs which are application VPCs and one shared services VPC, and want to able to communicate to the shared services VPC but not among each other on the application side, and being able to communicate from the VPCs to your on-premises, then you can use a routing table rules similar to what was shown in the diagram here. Also, with regards to Transit Gateway using in conjunction with the Direct Connect Gateway, what is the best way to influence routes? Well, you guessed it right. It's to use BGP local preference communities. As you can see on the screen, on the left side, you have 10.100.0.0/16 where you are using the higher community to prefer that route. If you choose a lower BGP community, then that will be a secondary route. Let's move into Transit Gateway best practices. First is using different autonomous system numbers per region. It is important to think about the strategy for Transit Gateway, Direct Connect Gateway, and your customer gateway autonomous system numbers when using transit gateways and make sure that they are not overlapping. The next best practice is to have redundancy built in. It could be your device redundancy, location dependency, or application dependency. Make sure your requirement is taken into account when you are planning. Similarly, when you are leveraging Transit Gateway, make sure you use multiple AZ so you have redundancy built in there as well. Next, use local preference communities to ensure predictable active and backup paths, which we discussed. Lastly, make sure to limit the number of Transit Gateway route tables that you manage. I want to provide you a cost consideration example because we are talking about migrations here. Example Corp had to perform a lot of data transfer. So what they did is they used Direct Connect to transfer the data directly to the VPCs as opposed to using Transit Gateway. Well, why did they do it? As you can see on the screen, Transit Gateway cost has 2 cents per GB for data processing. It doesn't matter if it is data coming in or going out. But if you are using Direct Connect as a standalone, there is no data transfer in costs. So that helps save cost when you're doing large data migration. I have provided a QR code for scalable multi-VPC network architecture white paper that can help you in finding additional architectures that will suit your needs. The last challenge that Example Corp faced is private DNS resolution. Why is it a challenge? Well, to understand this, let's take a look at how private DNS works within AWS. If you want to resolve a private domain, all you need is make sure you create a private hosted zone and associate it to the VPC. After which, when an instance wants to make a query to the DNS, it gets an answer from our Amazon Route 53 resolver. Similarly, if you have a different VPC in a different account that wants to resolve, you do the same thing. You can associate that private hosted zone with that particular VPC and you are able to resolve. What if you bring in your Direct Connect into the mix and connect it to your on-premise network? From on-premises, are you able to resolve the Amazon Route 53 resolver? No, it doesn't work. Why? Because the resolver resides in the actual host of the EC2 instance. So it's not reachable from outside VPC by default. So in the past, customers had used DNS forwarders to get around this issue. But it has its own challenges. First thing, you have to manage the EC2 instance yourself, which is an undifferentiated heavy lifting. Next, there is an ELI limit on the EC2 instance where you can only query up to 1024 packets per second per ENI. Next, with DNS, how it works, if one instance fails, then you take a downtime of 1 to 2 seconds. Why? Because if you think about how Linux resolver.conf works, it always prefers the first IP address in the specified in there. Only if it fails, then it will try the second server. Due to the same reason, this model can create a problem where if one AZ is having an issue, then it could impact the whole VPC. Well, the solution is to use Route 53 resolver to enable DNS resolution in the hybrid cloud. Customers can create conditional forwarding rules and endpoints that allow DNS traffic in and out of their VPC. How does this work? Well, on a simple example, you can see a shared services VPC which has inbound Route 53 resolver endpoint and an outbound Route 53 resolver endpoint. If an on-premise server wants to resolve a domain in Route 53 private hosted zone, all you need to do is specify a conditional forwarding rules to the inbound resolver endpoints, and that would make sure that the query works. Similarly, if you want to resolve the other way around, you can create rules, and in the rules you can specify the outbound resolver endpoint to point it to your on-premises. So this way you having private connectivity for DNS on both sides. You need to make sure that you have either a VPN or direct connect connection for IP connectivity in this model. Well, what is the pros for this? Well, it's a managed service. You don't have to manage the DNS. It provides increased resiliency. You specify the subnets where you want to host your Route 53 endpoints, and we'll create an ENI for you. And each ENI can have up to 10,000 queries per second per IP address. This enables you to have more scalable architectures. In addition, if you want to have more than 10,000 queries per second, you can create additional ENIs to scale it as well. Let's jump into some common questions we get from customers on this. Are resolver endpoints regional? Yes, absolutely. Unlike public DNS service from Route 53, the resolver endpoints are regional service. Do you need unique endpoints for each VPCs or account? Not really. You can use private hosted zone associations for inbound endpoints, and you can use resolver rule sharing using via the resource access manager service for outbound endpoints. So what you need to do is make sure that your VPC that hosts the inbound endpoints have all the Route 53 private hosted zones associated with it. That way you get a single DNS view which the Route 53 resolver endpoint is able to resolve. For outbound endpoints, you depend on the resolver rules. So make sure to associate those rules with all the VPCs that are in question. Example Corp set up a multi-account, multi-VPC strategy due to their scale. So let's look at some of the patterns that they can leverage to have a scalable solution. The first pattern is centralizing private hosted zone. In this model, as you can see, all the private hosted zone is hosted in the shared VPC, shared services VPC. This is for use case where a central team wants to manage DNS. We are leveraging a single inbound and outbound resolver endpoint in this pattern. The reason is because it is simple and cheaper. Because you only pay for the ENIs of the resolver endpoints, and having it in multiple VPC increases the cost. So you make sure you associate all the private hosted zones and rules to every other VPC and use the inbound and outbound resolvers only for on-premises to AWS and AWS to on-premises resolutions. So if you want to resolve from AWS to on-prem, you reach inbound resolver endpoints using conditional forwarding rules. Same thing for outbound. And within each VPC, you are able to use Route 53 rule association or private hosted zone association to be able to resolve between each other. The next pattern is decentralized private hosted zone. In this pattern, it is primarily used if there are individual teams who owns the VPCs and they want to manage their own DNS resolution. So the only difference in this model is the private hosted zone resides in the respective VPCs. But even in this model, it is going to be the same. where you will be associating the private hosted zone with all the accounts, mainly shared services, so it has the singular view of the DNS, and the resolution works absolutely the same way. I have provided a link or QR code for hybrid DNS white paper that myself and a few of my other colleagues wrote, which will give you more patterns on hybrid DNS. So moving into Route 53 resolver best practices, make sure you are leveraging high availability. This is making sure when you are creating the endpoints, leverage multiple subnets in multiple availability zones. Second one is use the forwarding sparingly. Use Amazon provided Route 53 for all the local resolutions and use the endpoints only for on-premise resolutions on a conditional forwarding basis. Third is monitoring. As we saw, there is a 10,000 queries per second limit, and make sure you set CloudWatch alarms to monitor that. So if you need additional, if you're approaching that limit and you're expanding, then you are able to create additional IP addresses or ENIs. Last one is query logging. So customers who want, for compliance reasons, or if they want to monitor query behavior, they could turn on DNS query logging and send it to targets such as S3, CloudWatch logs, or Kinesis Firehose, and consume it from there. So what are some takeaways and final thoughts from the start? Well, use your services in combination to meet your specific needs. Look carefully at your requirements and use services. For example, if you have 10 VPCs, you might be good with peering, VPC peering, right? Also, there is a lot of constant innovations from AWS, so be nimble with your architecture. The other important takeaway is make sure you design private IP address ranges without overlapping IP addresses. Make sure you put a good thought in for planning, your dev, test, and production environments and different regions, what private IP addresses you will be choosing, because this is very useful when aggregating the traffic as well as setting up security policies. Last, make sure you test and validate. This is very important. And with that, these are some of the major challenges that Example Corp faced and how they solved them using our AWS networking best practices. I hope this helps in successful planning of networking in your migration journey. Here are some resources to get started with migrations to AWS. Thank you.